This short lesson examines solving a system of equations by graphing. So say we have two equations right here, y equals 4x plus 1 and y equals 3x plus 3, and we want to find the value of x and the value of y that make both of these equations true. Well, one thing we can do to solve this is graph both of them and see where they intersect. Because remember, every point on the line of an equation makes that equation true. So if we find the point that they intersect, then that point would satisfy both equations. So let's go ahead and do that. So these are already in y equals mx plus b form, meaning this number here is the y-intercept. So for instance, just to give an example of that as a quick review, remember that every point on the y-axis, the x-coordinate is 0. So for instance, this point right here is 0, 4. This point right here is 0, 6. This point right here is 0, -3, 0, -8, and so on. So if we put 0 in for x, all we're going to be left with is y equals a certain number. Okay, so if I put 0 in for x right there, we get y equals 1, because 4 times 0 is 0, and all that's left is y equals 1, which is what was already listed right up there. So our first point that we can plot for this equation right here is 0, 1. So 0, 1. Now from there, let's apply our slope. Well, our slope is y equals 4x plus 1, is our equation, and our slope is 4 over 1. Remember, if there is just a whole number there, it can be written as a fraction where the denominator is 1. The numerator is our rise, and the denominator is our run. In other words, our horizontal movement. So here we go up 4 and to the right 1, since they're both positive numbers. So up 1, 2, 3, 4, and over 1. We can keep repeating that pattern and plot as many points as we like. Up 4, 1, 2, 3, 4, and to the right 1. So then what I can do is I have points here that have been plotted on this line, so I can connect the points with a line. Okay, so that is the line y equals 4x plus 1. So I'll label that. Now let's go ahead and graph y equals 3x plus 3. The y-intercept is 3, 0, 3, and our slope is 3 over 1. So up 3, 1, 2, 3, and over 1. Up 3, and to the right 1. So it actually lands on this point right here, which is over 2 and up 9. But I'm going to draw this line here, so this is what it looks like. So the point at which they intersect is 2, 9, and so that should be the point that satisfies both equations and makes both equations true. So let's double check. So first of all, again, I'm going to label this line right here. Y equals 3x plus 3. So we have y equals 4x plus 1. I'm going to put in 9 for y, and I'm going to put in 2 for x and see if it's true. So we have 9 equals 4 times 2 plus 1. Does 9 equal 8 plus 1? Absolutely it does. So let's check the other equation. Again, I'm going to put in 9 for y and 2 for x. So I get 2 in for x. 3 times 2 is 6. And does 6 plus 3 equal 9? Yes, it does. So the point 2 comma 9 is what satisfies both equations. And that is solving a system of equations by graphing. So, solving system by graphing. Okay, so there are 2 other possible outcomes that you could get besides one point of intersection. Okay? There is another possibility. So you could end up graphing a couple of lines, and perhaps it looks like this. The lines end up being parallel, and therefore they never intersect. If that's the case when you graph 2 lines, then that means there is no solution. There is no value of x and y that would make both of them true. Okay? So that's a second case. One other case that you could encounter is, let's say you graph a line like this, and then you're given different numbers, so what looks like a different equation, but then when you graph it, it ends up actually being the same line, one on top of the other. If that happens, then it's infinitely many solutions. It's not all real numbers because it's not this, it's not this, it's not down here. It's all the points on the line, and the line goes on forever, so it's infinitely many solutions. Okay? And that concludes this demonstration of solving systems by graphing.